So, there's this review, there's the test approaching, and I have posted on Google Classroom several documents of interest to thee. Let me go find some of them if I can. I'm having a little trouble with some googly things. I don't know why. Let's go to Google Classroom. See if I can. And if you go to Google Classroom, you will find that, because I can't log on apparently. Let me see if I can find it. There it is. This is the one I wanted. Let's try Google Classroom on this one. That was Kieran as a little guy. Anyway, if you go there, it looks grand. I'll show you. It's actually on my iPad, better than anywhere else. Here you go. Grant Ryan, you are kind of, I know, you're ready to hang in there, right?
Is this due on Monday?
So there's the Google Classroom Term 1 test review and key. I did not print this because I don't know what happened. We all got cut a bunch of copies. Like, I cannot print or copy anymore between now and the end of the month. So I'm trying to figure out how that's going to work. I got a cut back. So that, and we have no tissue papers or toilet paper around here. So it's just a big cutback season. This is what you're looking at. Go find it. Gentlemen. And the other part I wanted to show you is I have, if you look at it, it is model, it's got all these lovely, this is the key that goes with it, so it's all worked out. But you want to tackle these and not look at the key until absolutely necessary, and then start building your questions on Monday. It has some length to it, and that, remember, is in addition to, because I'm that cruel, there's a Term 1 review assignment that you have that you get to do. Like, here's Mina asking me about number 8. You guys are going to ask me, what does bounded mean? And bounded means, does it have an upper bound or a lower bound? And you guys know this is a cubic. It's a negative. It's a negative odd graph. It's not a positive odd. It's not a Todd. And that has no bounds. Like, the arms go up and down forever. And I'm Ryan. I don't know where I'm going to put you, but it's going to be somewhere over here. Duh. The function is not bounded because there's no upper and lower. Bounded means, does it have an upper bound or a lower bound? And a graph that has x cubed, like, it's just unbounded. It grows forever. That's what unbounded means. It's like, it's big. So it's not bounded, and you put it in there and it says, great job. But I can't get it to say great job because I'm looking at Mina's. If it's a parabola, right, facing up, it would be bounded on the bottom, lower bound. If it's upside down, it would have an upper bound. If it were like a logistic curve, it has an upper and lower bound because it has top and bottom. But that's all it means. So when we do it now, you'll have a better sense of what I was asking for. So now, back to the graph, the sheet that I was looking at. Go Notability. Let's tackle this. So you guys tackled this and you have no calculator. Did you know that? This is me saying you need to know how to do the parent function is absolute value of x. And like any good parent, it just magically bestows characteristics on its youth, whether they want them or not. This one is left 1, down 2. Those movements and your ability to notice them are really, really important on this particular test. And then there's a vertical flip, which means it's upside down.
This is for the final?
Yeah. So this is the review part 1 that's in your hands at your desk at the moment.
Quick question.
Yeah.
Do you have to have the graphing gateway taken before term Tuesday starts? Or
It's flexible.
could I take it Thursday?
Yes. And I'm actually, yeah, there's definitely flexibility in there. So don't panic about that. So now, domain-wise, that conversation for another non-recording day. So if I were to do this domain,
Oh, you recording?
yes, it's a negative infinity to infinity. You're fine. The graph of this one, negative infinity to infinity, is the domain because it's the absolute value graph. Sorry, I'm having trouble with my iPad. The range is where you have to know something about the function. So look at this function that went left 1, down 2, and I'm going to ask, none other than Ben Parks. Do you happen to know the range of this? I'll give you a hint. It's negative infinity until a number that would indicate the top of that upside down absolute value that got moved left 1, down 2. you happen to know the upper bound? You got it. So range is negative infinity to negative 2. And the bracket is essential because it does touch. So you got to have things like that in there. Increase and decrease stuff. Increasing and decreasing by itself is not a difficult idea. Like, hey, it's uphill on the left and it's downhill on the right. In color, I put it up there. The deal is, though, how you indicate it is in terms of an x interval. So increasing, you want to make sure you go, it's increasing on the left, which is from negative infinity x until the x that negative 1 is the x where the peak stops, and then it decreases from x value negative 1 to infinity. It's all about x values. These are x intervals. X intervals. Got them. Continuous or discontinuous, did you have to lift your pen? This one is continuous. No. Boundedness, this one is bounded above because there's a roof, a top. It's held back in some way. Now, 1-to-1. 1-to-1 means the function, func and inverse both pass the vertical line test. They both have to pass. If they don't, then it's not 1-to-1. So the vertical line test is for functionality, and I can tell you how quickly this goes. This is, an inverse is a reflection over the y equals x line, but for practical purposes, what you can think of, here's the absolute value of x. Here's its inverse. If it turns it on its side. So when you do an inverse of a function, it takes that function and rotates it over y equals x. Stuff that goes up goes right, things that go down go left. It literally turns it 90 degrees on its side in addition to doing some other things. It does move around a little bit. So all you have to do is imagine, what if I put this thing on its side, would it pass the vertical line test? And it actually doesn't matter which way you face it. Just think of, take the function, put it on its side, would it pass the vertical line test? That would determine whether your inverse would pass the vertical line test. It's a quick fix. Some people try to do what's called the horizontal line test, but I like you to think of my function, an inverse has a rotation, so it kind of turns sideways. They both need to pass the vertical line test to be 1-to-1. This one does not. Original definitely does, inverse does not, so I'm going to say N-O Niet. So, throwing a little, I think that's Russian, right, for no? All right. Radical. B was scary for some because it wasn't your regular parent function, but now that we got a picture up on Desmos on Coleman's calculator, right, you got a picture of this. It goes like this. It's rational. All you got to do is say, I need my ha. It's bottom heavy. It's bottom heavy. More degree in the bottom. Half a degree is more than no degree on top. So square root counts as a half degree. Does it have vertical asymptotes? Anything x can't be on the bottom? Sure, -2. Can't be -2. So x cannot be -2. X equals -2 is a vertical asymptote. We got some stuff to go off of. So if I even drew that much in like a random, really, really, really rough sketch, I would go, all right, y equals 0, I gotcha. Put you in pink. Maybe. There it goes. And then x equals -2, gotcha. And then I do my graph in purple. I know what this graph looks like. It's going to have some kind of like maybe 1/xe look kind of in those little, it's going to be somewhere in between those pink squares. There's one more thing we know. If you do the domain on this thing, it's really important. You guys remember radicals and denominators are the only domain limitation that we've got. So Grant, what do you remember about radicals? What do you think about that square root of x plus 2 thing?
Can't be negative.
No way negative. It's got to be greater than or equal to 0, but
It can't be 0.
0 is a problem when it's in the denominator, so I actually need to take that little part off. So it's just greater than because it's in the denominator. So that means x is greater than -2. That's my domain. Now that's actually a nice way to write it. So what happens with this graph is it actually only It has a horizontal asymptote of 0. It has a vertical asymptote of -2. It's greater than -2. If I plot just one point in this whole graph, I know that my graph either lives somewhere in here. Watch, I'll put it in yellow. It's in the yellow region, or it's in the orange region. It's one of those two places right there. Somewhere in there. Because I got all this evidence. And it's going to snuggle those asymptotes. Snuggle, snuggle, snuggle. There's two asymptotes. It'll snuggle them. Watch, I'll show you. All I need to know is which quadrant is it in. Is it up above or up below? You plug one point in there. Just put in like 0. X equals 0. If I put it in the function, and I'll put it in right here, I'll show you. Pink. Well, let's do red. Put in 0. You get 1 over the square root of 2. 0, 1 over the square root of 2 is like right there. Bingo. That means this graph looks like this. Snuggle, 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 snuggle. It just snuggles. Most of these graphs you'll have some access to, but I wanted you to know with asymptotes, domain, and a point, you guys can make anything happen. You just make it snuggle the asymptotes, and you got this graph. Check your calculator, it'll show you. There's our domain. Range means it's from 0 on up. It gets bigger and bigger and bigger, 0 to infinity. Increasing, decreasing. This baby, as you read left to right, is always downhill. So decreasing always for all row. Continuous or discontinuous, it's nice and continuous for its domain. There's no pen lifting. Boundedness, it's got a bottom. So we say bounded below. Juan to Juan. If I turn this on its side, it would kind of look like, watch this. It would just kind of turn to the right. And it still passes the vertical line test either way. An inverse, now that's a really, really, really terrible inverse. If I actually want to draw the inverse, I reflect it over the y equals x line. It actually looks almost the same. But in the end, they both pass the vertical line test. So this one is called 1-to-1 because both that and its sideways counterpart, the inverse, would pass the vertical line test. That's a start to this review process. That's part 1. Now I'm going to kick off, I'm going to close this video and do another one.